Hello and welcome to Bootcamp on R. Thanks for watching, and if you're new here, make sure to subscribe to get good quality content. This series of tutorials aims at helping you before regression analysis. So it will go through everything that you need to know before a serious regression analysis. We will talk about data types, objects in R, functions, loops, and R programming. We will also talk about different data types and their operations. So make sure to follow through before you get serious about an analysis. This way you have a way better chance at coping with everything that you need to know while doing the analysis. The R tutorials in here will guide you step by step through business statistics, yet they can be applied in many other domains. R is used by researchers, scholars, and businessmen and women to analyze data, for example, to predict future profits or extract important key factors. During these tutorials, you will also be getting access to discounts and free coupons for other professional courses in R. You can follow along from your cell phone or your laptop to grow your knowledge and learn something valuable. I recommend coding along, as you will learn the most in this way. These tutorials will teach you everything you need to know about regression models, statistical validity, data objects, and how to write your own functions and programming in R. By following along, you will build your regression model from scratch to advanced levels in no time. Every bit of code that is taught here is focused on being used in real projects which help your understanding about business and advertising, for example, if that's what you are interested in. If you have any specific requests, make sure to leave a comment down below, and I make sure to take it into consideration for the upcoming tutorials. That being said, let's get down to R. So, what can R do for you? R is a statistical language. It is therefore associated with mathematics, and econometrics, for example, is the science of expressing economics in mathematical or statistical model form to solve diverse problems. The R console is used for R programming, and we have the R console here. This is the R console. If you don't have it, you can just go to rstudio.com, products, and then choose RStudio here and download the desktop version. Like every other programming language, it has a language associated with its use, and we apply that language in here in the console. So, for example, to print a string or hello world, you would use this function here, print hello world. To add two numbers, you would add 3 plus 8 and press enter. That gives you 11. So the scope of this tutorial is to focus on data objects, data types in R. We will be talking about vectors, lists, arrays, and matrices in this lecture. So data type in R, it allows you to create many types of data storage objects such as numbers, vectors, matrices, strings, or data frames. It also lets you do programming and using various variables to store various information. The variables are reserved memory locations to store values. So in R, you can store information on different data types, and we have character, integer, floating point, double floating point, and boolean. So in the R programming language, variables are not declared as some data type as is common to do in other languages. Variables in R become R objects, and the data type of each object becomes the data type of the variable. So R objects and the data type is defined by the R variable. Now there are many types of objects in R. We can see here some examples. We have the vectors, we have the lists, we have matrices, arrays, factors, or data frames. Now what are these good for? Every time you use R for a statistical analysis, you will need to know how to handle the input, the output, and the regression types that you associate with your analysis. Some good example of vector data types. We can see here a vector can be logical, for example, that is true or false. So we have it here. For example, if v equals true, v, you assign the value v, and you assign the value true to the vector, to the logical vector, you can see that v here contains the word true. Now if you print the class, I'm just pressing arrow up to get all my previous input, it tells you that the class of v is logical. Vectors can not only be logical, they can also be numeric, that is numbers. So we have here a vector which is 5.5, and v here we see it contains 5.5, and if we print the class of it as we did before, we see it is numeric. We also have integer types, and in this way we assign the value of 2 liters to R, for example. So v assigned 2 liters. Then you can have the class of v to show you the type, and it says integer. Atomic vectors, or double type, which we also call them. All vectors in R are called atomic vectors, and an atomic vector of type double would be 12.6, and if we print v, we see here it's 12.6, and if we now type the class of v, so complex vectors we create when we need to enter different types of information inside the variable, and we can see here that v is 6 plus 5i. This could be useful, for example, in loops or anything that you want to use complex objects for. There's also the character type, which is letters. So the letters, the character type we have here could be A, or good, or false, or 51. So a character type of variable, for example, containing the letter A, or the word good, or false, or even 51, which is in letter shape, we would type it as a character class. Now we have the true here, but the true no longer is of logical type but of character type. So you put the words inside single quotes or double quotes for R to know it is a character type. And the last type that we have is raw, and that is when R stores objects in its memory in machine text form. And we have v here, which is character to raw format, hello world, for example, and we can see that the value of hello world is 4865. Now this is hex code, it's what machines talk, It's less of important for us, but nevertheless it's important for the calculations going on inside the machine. And R, as you know, is a compiler. The most fundamental numeric data type in R is an unnamed vector or a scalar. And the scalar is nothing but a vector of length 1. So we have v. If we assign 1 to v and print v, we see it is a one-dimensional vector. That's a scalar. When creating vectors with more than one element, the C function, concatenate function, combines the elements into the vector. So we can create a vector, for example, colors, which contains the color red, purple, and green. And we can print these colors. And we can see here, it prints out red, purple, and green. Now these are values stored inside a vector, which has 3 elements. Vectors do not contain information about whether they are rows or columns, but R usually assumes that they are columns. So R is very flexible when stacking vertically or horizontally, and everything depends on your commands. For example, if we have 2 variables here, or 2 vectors, A and B, A is concatenating 1, 5, and 10. B is concatenating 2, 4, and 6. And we can print A to see what's inside. A shows exactly the values we entered. B shows exactly the values we entered. And to bind them by column, we can C-bind the values like this. So you use the word C-bind, and the first and the second vector, or the nth vector that you would like to bind together. Now if I print AB, you see I have the vectors here, and they are stacked column-wise because C-bind is for columns. We also have R-bind, which is to bind them by rows, and in that way you get a different outcome. Let me show you here the R bind. So CD, that shows us the values by row. So A is on top, B is below. To make this a matrix, you would use the as matrix function, and we can see it in action here. AB as matrix, and then if we print AB, we see it is now a matrix. T, the function T, transposes a matrix, that means turns it around. So to transpose a matrix, you type T and what you are transposing. So in this case, T CD, transpose CD, that gives us the values from CD here, but column-wise. Before they were row-wise. Now, true vectors in R, as opposed to one-dimensional matrices, are treated as column vectors when a distinction needs to be made. So we have the F here, F variable here, which uses C, our function C, which we talked about, to concatenate the values 5, 6, and 15, so they can be used on multiple types of data. The command cbind, which we used before, concatenates objects given by arranging them side by side. It's into an array if it's vectors, and into a single data frame if they are columns of named data. So we have a data example here that we see, and DAT, the data object, cbinds First, this group, which is concatenated, this group of integers, and then the second group of integers, and it binds them column-wise. If it is multiple types of data, it will bind it into a data frame. So DAT here, that is what we have, the values of the second group and the values of the first group. Now this is still a vector. We will discuss data types before, but you can see here structure. If I type structure DAT, it will show me the structure. There we have it. It's a numeric vector. So if it was a data frame, it would say data frame. We will talk about data frames in the next tutorial. We also have the R bind, as we talked about, and it assumes that the vectors it is given are row vectors. That is why when you bind them by row, it assumes all vectors are given by row. When you bind them by column, it assumes all rows are bound together by columns, not by rows, as R bind. So if we were, for example, concatenating strings instead of numeric values, we would have to put the strings in quotes. We will also discuss strings specifically in the next tutorial. Elements in vectors and similar data types are usually indexed using square brackets. And I will show you an example here with our variable f, which we created. So if I print out f, it gives me the values we entered. Now if I type f square bracket 2, it will give me the second position inside the vector. So all elements in vectors or similar data types, they are indexed. R indexes its object and its positions using square brackets, and it's one-based indexing because you access the one object that you need or more by one. All right, the next data type that we will discuss are lists, and lists are made of different data objects bound together, optionally with a name given to each. A list can contain many different types of elements inside it, like vectors, functions, and even other lists. So if we create a list here, L1, we can see that it contains the concatenated values 1, 2, and 3. It also has a float type 1.5 and the cosinus, which is a function. Now if we print a list, we type L1 and that gives us the list. We can see the positions here, which clearly reflect where the values are stored within the list data type. So number 1, position number 1, double square brackets, which we use for lists, I will show you soon. It contains everything we concatenated in the first position. The second position of the list only contains the float 1.5, which we entered here. And the third position contains the function which we specified, the cosinus function. So the same as with data frames, we can see that objects in a list by name, if they have names, we can call them. So let's give our name, let's give our list some names by the type of the vectors that we used. So we see here the names I've given to L1 are numeric, float, and function, because those are the types we used. Now if I type names L1, it will show me the names I just gave the list, and those names I specified up here within the double quotes. You can also access elements of a list and of a data frame. For example, 81. Then we have the $sign, and let's use the function column. So I type function. This will give me what's inside the third column here, the third list position. So referencing the member of a list is generally done using double, not single quotes. So let's see if I would like to print just the first position of the list. I would type double brackets, position 1, and then 1 to 3 prints. You can clearly see it here because that is the first position. That's how you access it. Whereas here with the F that we used, you can see that the second position is accessed with single brackets, single square brackets. Okay, so if we want to make them into a vector of strings, we must change the list to a vector using a command called unlist. So if we use a new variable a to store our list in and give the command unlist, we can see here that a contains all of the elements of the list but per individual number. So it has given the list new names. The first one is numeric 1, the second is numeric 2, which contains the second value of it from here. The third one is the float, and the last one is the function which we entered. So we can see if we type structure A, the new A element that we did, it gives us a list unlisted of 5 values. Whereas if we take the structure L1, it will give us a different output. See, that is a list of 3 elements, and one of them is an array, a numerical array. That's how you unlist lists if you need all the elements. We will talk more about manipulating data and everything data operations that you can do. This is all for lists for this lecture. Let's go further to arrays and matrices. So these are pretty similar, but a matrix is a 2-dimensional object, while an array can be of many more dimensions, as we just saw in our lists. So to create an array, another type in data type in R than a vector, so we type whatever we want in the matrix. I have a good example here, and my example shows here create a matrix where M is our matrix, concatenating a different type of value. Here we have letters and we have small and capital letters. The number of rows that I would like is 3, the number of columns is 3, and I would like to put the matrix together by row. Now let's see our matrix. As specified, it has 3 rows, 1, 2, 3, and 3 columns. And my values here are concatenated by row. So X, X, O go into the first row. Alright, to transpose the matrix, we will use the T function because matrices can be transposed. And I store these values into the variable m, small m. So the reason why a matrix is transposable, it's because it's made of column vectors, and R can just throw them around into rows or columns as you like. 2 objects in R is case sensitive, and we can see here that capital M and M are not the same variables. They are different ones. We get 2 outputs. They are separate because of the data sensitivity in R. Okay, so I said that matrices are two-dimensional, while arrays can be of a many number of dimensions, and the array functions take a dimension attribute to it, which allow us to create arrays of different dimensions. So, for example, an array with 4 elements, which are 2 times 2 matrices each. I will print this in here so I don't confuse you. So, an array with 4 elements, which are 2 times 2 matrices each, is created like this. We assign a variable name. We assign the values, which in this case are green and yellow. We concatenate these because we want a 2 times 2 dimension matrix and we want 4 elements. So we see that these matrices of 2 times 2 dimensions each showed up 4 times. Now if we take a look at the structure of A, we can see that it's a character type, but 1 to 2, 1 to 2, 1.4, because that's how we define the dimensions here. So the matrix dimension, two-dimensional, it contains the 2 times 2, and then we have the 4 elements inside the array. Okay, so what else? For multidimensional data types, such as matrices, which we just discussed, and data frames, by leaving an index blank, you refer to the whole column or to the row corresponding to that index. Now, if we take our matrix M as example, if I print M, as we did before, M will print the whole matrix on the screen or array. The first row can be printed by leaving an empty index, as I just said. So I am specifying that I would like the first row, comma, and then leaving an empty index. And that prints the first row. Now if I would like to print the column, the third column, let's say, I will put the comma before and I will get the first column, not row here, but column. And we can see here the first column is XOX and the first row is XXO. And that is how you use the comma to print whatever you need. Sometimes you need to get values out of an array or out of a matrix to use them in further analysis. Sometimes when you do regressions, you need to get out the residuals from a regression summary, or you would like the t-values, anything. You need to be able to access those values, and the summary output of regressions is usually a list. We'll talk more about this in manipulating data types and objects in the more advanced tutorials coming up. We can get the summary statistics, for example, of M. We can type summary M. You can do the same with the regression model. We will go through that too. But summary M, we see here, it has a vector with 2 values, which is our 2 variable dimension number 1. Then we have the second vector, which is the second dimension within that we specified within. And then we have the 3 dimensions, which take in all these values in a third. We can determine the dimensionality type of a matrix or an array by number of rows. And we see we have 3 rows here. We can also use number of columns and col to get the number of, yes, you guessed, columns. There we have it. Now, more generally, we can use the dimension command to know the dimensions. If we didn't know what the matrix contains, let's say it's a very big matrix and we need to use it, we just type dimensions dim command M, and then you get the rows and the columns. If I would like to extract, that is subset the data, let's say we have a very big M matrix again, or data frame that we would like to use in our analysis, then you can do that by the concatenation operator. And let's say I want to get the first and third columns of our matrix for demonstration purposes, and I do that here by typing odd M, which are all the odd rows, all the odd columns, sorry, in M, and I concatenate the first column with the second column. So this makes a 2 times 3 array out of the columns 1 and 3 of M and saves it in odd M. Now if you compare this to what we have here, you can see the third column has a capital O, small o, and an X, and you find them here in the second column of the new odd M object, whilst it was in M third column. So if you would, for example, like to take out let's say column 2, then you would use the non-odd the subtraction operator, and you type no odd M, that is M where we would like to subtract the columns. See this column here tells you column wise. The minus here tells you to get everything but column 1 and 3. So no odd M gives us the second value here, XX0. We can also use comparison operators to extract certain columns or rows. And if, for example, our M would be numeric, then we could use these to get values greater than 1, for example. Now, our M does not contain any integer or numeric values, so we can't see anything that's less than 1, but you get the idea. You can act on your data as long as you know how it behaves. So the point of this lecture, this introduction to vectors and their types and the arrays and the matrices, is for you to be able to access elements. The list, the most important thing to keep in mind from the list discussion is that you usually use double brackets and that you usually have a list when things get more complex. And when they are complex, you can always unlist it to get all the elements you need. We will talk more, as I mentioned, about accessing elements of a list, like regression model outputs, which are list form, in the upcoming tutorials. So in the next one, we will be discussing factors, strings, formatting numbers and strings, recycling elements such as vectors. We will talk about date and time objects, how to create and handle variables, and how to determine the type or class of an object in R. So if you haven't subscribed yet, go ahead and subscribe now, and do not miss out on valuable content. Also, if you like these tutorials, please give them a thumbs up. I hope you're enjoying learning R. Knowledge creates mastery. Thanks for watching, and see you in the next one. There's more good content coming up.